Okay, so I'm so excited to start using these recordings to try and help you guys when you are struggling on these problems. First off, this problem is Unit 2, Part 2, question number 3. Write an equation in which the quadratic expression 2x minus 2x minus 12 equals 0. That's the first part. Then we need to show the expression in factored form. And finally, we need to explain what solutions mean for the equation. And as always, you got to show your work. So first thing it says is write the equation for when your expression is equal to 0. So all I have to do is write the expression and make it equal to 0. Nice and easy. Then part 2, so that's part 1. Part 2 is to show the expression in factored form. So we need to factor this trinomial. As you know, when you factor, you are usually splitting the trinomial into two sets of binomials. But there is a catch on this one. What do you notice that all of the numbers have in common? They all have something in common. If you look at the numbers, they all share a factor. Wow, and I wrote something wrong, guys. Look at this. See, this happens all the time. Let me erase some stuff here. I wrote down the problem wrong. It's minus 2x. Whew. Okay, back to what I was saying. 2, 2, and 12. They all have a common factor that you would need to take out originally, so we can't even do that part yet. They all share a common factor of 2. So if we're going to divide each part, 2x squared divided by 2 would give us x squared. Negative 2x divided by 2 would give us negative x. Negative 12 divided by 2 would give us negative 6. So basically what we did there was we factored out a common number. Okay? We took out a GCF, greatest common factor. Now we need to get back to what we were talking about. We need to factor our trinomial into two binomials. We can decide how to do that by looking at our last term. That number is going to be our guide. We have to find two numbers that can multiply to equal that last term, and they need to add to be this middle term. And the middle term has a leading coefficient of 1. So whatever these two numbers are, they need to add to give me the coefficient of my middle term, which is 1. So you're going to make yourself a little tree here. Negative 6 can be broken up into 1 times negative 6, or negative 6 times 1. So those will all get the following, multiplication rule, but neither of those will be able to add together to equal 1. So those won't work. So we'll keep going. So what about 2 and 3, or negative 2 and positive 3? Okay, so those both multiply to give us negative 6. We're good on that. But only one of those will add together to give us a negative 1. It's supposed to be negative, guys. If you look here, it's a negative 1 in front. So they have to add together to give us a negative. So we need to have the negative number greater. We know that if we have 2 and negative 3, they will add together to give us negative 1. And 2 and negative 3 will multiply to give us negative 6. Yay! So we factored 6 into these two numbers. And those two numbers will be placed inside the parentheses, the second term of both binomials. So the first one will be 2, second one will be negative 3. And then all you have to do is you know that you're splitting up your x squared into the first two terms. Wow, I'm trying to change the color back into black, but it's not. There we go. This x squared will split into the first two terms, which is x and x. We know it was a positive 2. You still have your 2 in the front. Now, we showed our expression in factored form. Boom. But it's saying the next part we need to explain what our solution means for the equation. So number 3, what is our solution? We haven't even gotten there yet, which is kind of crazy. I was trying to see if I could get some more. Okay. So, a solution in this quadratic equation is isolating x, getting it by itself. We are setting each part. There are 3 parts. Each part needs to be set equal to 0. Because if we want this entire equation to be equal to 0, one of these pieces has to be equal to 0. The only way you can get the answer of 0 is if you're multiplying by 0, right? One of these needs to be 0. So we can say that 2 is equal to 0 from this first part, and really that doesn't make any sense. So let's set the second part equal to 0. And then let's set the third part equal to 0. Okay, so now we can work with these 2 equations. We need to isolate the x and get it by itself. In order to do that, we're going to get rid of the 2 by subtracting it, doing an inverse operation on both sides. Positive 2 and negative 2 will cancel out. We'll have x equals negative 2. So that is one of my solutions. Now we need to look at our second piece there. In order to get the x by itself, we're going to add 3 to both sides. Negative 3 and positive 3 will cancel out, and you'll get x equals positive 3. And we finally have our solutions. Ultimately, what do our solutions mean? On a graph, if you were to graph this parabola, these 2 solutions would be where the parabola goes across the x-intercept. These x's are where your y is equal to 0. And that's what the solution means. These are your zeros, your solutions, where your y is equal to 0.